Hey, what's up, Rico? Sorry I couldn't be there with you today, but my wife got what I got on Friday, so her being pregnant and all, I need to kind of stay home and take care of her. But I didn't want to leave you high and dry, so what I'm gonna do here is kind of go over some things that you saw on the worksheet from Friday. I think it was called Trig graphs and applications. So yeah, I wanted to show you a couple things here that you kind of, I mean, you have the knowledge to do. I just want to show you some specific examples. So I'm going to start with some general ones and then get into some specific ones off of that worksheet. Okay, so first thing I want to teach you to do is like, if I were to give you like specific characteristics of a graph, you being able to come up with the equation. Okay, so I'm just going to make up something real quick. So let's say I wanted a sine graph, right? That had a, let's say an amplitude of 7. Let's say it had a period uh, 6 pi, something like that, and a midline of um, y equals -3. So let's say I want to create a function like that. So um, amplitude midline should be pretty easy, right? So like if you want the amplitude midline, that's the a value, right? And that's your d value. All you have to do is say, okay, y equals 7 sine, right? And then come back here, throw a -3 back there, and you're good. You could even, I mean, if you wanted to, you could do a -7 if you wanted to, but like it doesn't really matter. But you're most of the way done right there. You're 2/3 of the way done. All you gotta do is figure out this period. So the period, think about it. What variable does the period have to do with? The period has to do with b, right? So we just gotta figure out this b value, and we're done. So if you recall, the sine function has a period of 2 pi originally, right? And I told you that 2 pi over b gives you your new period, right? Well, guess what? I'm gonna write exactly that. 2 pi over b equals my new period. So watch this. 2 pi over b equals 6 pi, right? See that? And what I'm going to do here is I'm just going to make a little equation, okay? So if I take 2 pi over b equals 6 pi, and I say, okay, well, 2 pi times 1 would be 2 pi, right? And 6 pi times b would be 6 pi b. Well, how do you solve that for b? You just divide both sides by 6 pi there, you see? And 2 pi divided by 6 pi, pi's cancel out. 2 over 6 would be 1/3, right? So look, b is 1/3. So all I have to do, see right here, you could come in there and you could either put a 1/3 x or you could put x over 3. It doesn't matter, but let's just say I did 1/3 x right there, right? See that? This has all these. This has all these characteristics right here. See the amplitude is 7, midline is y equals -3, and if I took 2 pi, basically you see how they're dividing by 3. If you multiply 2 pi times 3, you get 6 pi, right? So that's how you can do that, right? So what I want to do real quick is I would like to just go through a couple, just 1 or 2 examples with you from that worksheet. By the way, the answers are all online. Everything's online. But let's say I looked at number, I don't know, number 3. Okay. So number 3 says this. It says you got a tangent graph, right? So we got a tangent graph. We got a phase shift of pi over 4. That's a positive pi over 4. So that's to the right. And it's got a period of 9 pi. Okay. So this is what we have, I believe. All right. So tangent graph, phase shift pi over 4, period of 9 pi. Okay. Obviously, we don't talk about amplitude on a tangent. Midline is just going to be y equals 0, so there's no d value. So what we're going to do is we're going to try and figure out the phase shift is kind of, that's just that c value. So that'll take care of itself, but we got to figure out what this b value is. Okay, now what's the original period of a tangent graph, right? It's not 2 pi, it's pi, right? So instead of 2 pi over b, what I'm going to say is pi over b equals 9 pi, right? So watch this. If I say pi over b equals 9 pi, just like that, all I have to do is do a little cross multiplication. Like 1 times pi would be pi, right? Equals 9 pi b. And if you divide both sides by 9 pi, what's pi divided by 9 pi? That's right, kids. 1/9. Okay. So b is 1/9. Now watch how I'm going to do this, okay? What I'm going to say is y equals tan, right? I'm going to put parentheses, right? I'm going to put 1/9, okay? Now if you recall, if I want to do this easily, I'm going to separate it by 2 sets of parentheses, right? So what I'm going to say is, I'm going to say x, remember phase shifts are opposite, right? So I'd say minus pi over 4 like that. And this would be the easiest way to write that, just like that. Now if you want to be extra, you could distribute that 1/9 through there, but I would just consider writing like that. You can see, look, there's the phase shift of right pi over 4, right? Which is right here. This is hard to do here. And then you can see that it's got the b value of 1/9. Okay. So that was number 3. Okay. I would like to take a look at number 5. Okay. So 5, some of y'all probably looked at it and like, forget it. I'm not going to even try that. But it is an important problem. So 5 is, it's basically like a type of problem where you have something like repeating values over and over again. So if you think about like a Ferris wheel, like if you go around and around and around, over time, you hit the same heights over and over again, right? So if you were to graph it like this, it would look like a sine or a cosine graph because you would just keep seeing the same heights up and down, over and over again, okay? Some other things do that, like temperatures throughout the year do that. There are a lot of periodic functions where they kind of repeat the same things over and over again, and those can be modeled with a sine or cosine graph. Either one would do, depending on how you set it up, okay? But if you look at this one, I want to go through this one with you step by step and make sure you understand it. But it says a Ferris wheel with a radius of 25 feet is rotating at a rate of 3 revolutions per minute. Now, if it goes 3 revolutions in 1 minute, how many revolutions, or how long would it take to do 1 revolution? Well, if it does 3 of them in a minute, if you take a minute, which is 60 seconds, right? Divided by 3, what's 60 divided by 3? Well, it's 20 seconds, right? So I want to tell you right now, this Ferris wheel has a period of 20 seconds. That means in 20 seconds, it's going all the way through its rotation, okay? Now I'll get back to that in a minute. Then it says when t equals 0, so t is like time, right? A chair starts at the lowest point of the wheel. So if it's at the lowest point, it's got to be going up after that, right? So if you think about that, like let's just say I have like a time 0, right? If you start at the bottom, you're going to go to the top, and then it's going to come back down to the bottom, and it's going to repeat that like over and over again, okay? Now, that's a really crappy graph, but if you look at that, start at the bottom, middle, top, middle, bottom, right? We'll get back to that, but that's kind of how it's going, and then it does it again and again and again, right? This would be like time 0 right here, okay? But that's important information as well. Now, let's see what else we have here. It says when you start at the bottom, you're 5 feet off the ground. So basically, at the bottom, like right here, basically this is going to be 5 feet, right? Okay, and think about it. If it's 5 feet and the Ferris wheel has a radius of 25, right? If the radius is 25, what's the diameter? Well, it's 50, right? So guess what? If you're at 5 and then you're 50 up, guess what? This top right here, see this? This should be 55 feet. Okay, so that's another piece of information. Let's see what else we have. And it says write a model for the height of the chair as a function of time, right? So basically, height's going to be our output, like our y, and t is going to be our input. So we should be able to put in a time and see where it is on the Ferris wheel, right? So here's how we're going to do that. We need a couple things. And I kind of walked you through like each step with A, B, C, and D, right? But basically, here's how you could come up with that function, okay? First off, looking at this right here, does that look like a cosine or a sine function to you? And you might say, well, neither one really, because a sine starts in the middle, right, and goes up, and a cosine starts up top and goes down, and you'd be right, okay? But here's my suggestion to you, okay? If you ever start at the top or the bottom, like in a periodic function, I would probably go with a cosine graph. And you might say, well, how's it going to make cosine start to the bottom? Well, guess what? If I put a negative in front of that cosine, instead of start at the bottom, it's going to start at the top, it's going to start at the bottom, right? And if you ever start in the middle, I would go with like a sine function, okay? So basically what I would do is I would go ahead and say, okay, I'm going to use y's and x's for right now, just so I don't confuse you, but I'm going to say y equals cosine, okay? So I know it's a cosine function. And even more so, look, since it started at the bottom like this, I'm going to make it negative so it flipped, okay? Now, what goes here, right? Right here would be the amplitude. So let's think about this. The amplitude is how far we are off the midline, right? Now let's think about that. If this is 5 and this is 55, what would the midline be? Well, what's 55 plus 5? 60, right? What's 60 divided by 2? 30 feet, right? So 30 is the midline, right? Well, guess what? You know how far up and down it is from the midline? It's 25 feet. And guess what? That's the radius, right? So guess what I'm going to put right here? The amplitude is going to be 25. Okay. Now, that 30 is something as well, isn't it? What's that 30 going to be? Well, that 30 is going to be the midline. Okay, well, where does the midline go? The midline gets tacked on back here, right? See that? So let me write this a little better. Hold on. Negative 25 cosine, right? Now, what I need to do is I just need to worry about like what goes in here, okay? Because what goes in here is going to determine the period, right? Well, how long did we say it took for this to do one rotation? Well, if it does 3 of them in a minute, a rotation would be 20 seconds, right? So on a cosine graph, right? On a cosine graph, we always say 2 pi over b equals the period, right? Well, guess what the period is? It's 20. Okay. Do a little algebra. Watch this. You get 20b equals 2 pi, right? And if you divide that by 20, you get b equals 2 pi over 20, which would be pi over 10. So guess what? I just put right here, I put a pi over 10 with an x, okay? This models this function right here, okay? This would start at the bottom, it'd go up, it'd repeat every 20 seconds, okay? Because guess what? If I put a 20 in here, 20 divided by 10 is 2 pi, right? That's one period on a cosine, okay? And there you have it. And the only adjustment I'm going to make is they said, look, instead of y's and x's, they want height in terms of, watch this, time. So now I have a function where if I put in a time, I would get out a height on the Ferris wheel, right? So you could put in any number of seconds and you would know exactly where you were on the Ferris wheel, okay? Now, could you do it with a sine? You could, but you'd have to have some sort of phase shift, which would be probably a lot more difficult, okay? But point being is if you start in the middle, you're probably going to want to go with a sine graph. But if you start at the top or the bottom, you're going to want to go with a cosine graph, okay? So saying that, I just want to do one more example and kind of show you how you can look at a graph and figure that out as well. So watch this. I'm just going to make up a graph here. I don't know. Let's see. So let's say I have a little graph like this, right? Okay. And I'm just going to make up some points. I don't know. I'll say this could be 0, 6. I don't know, 3, 9. 6, 6. That doesn't make sense because that would need to be, hold on, let me adjust this real quick. This would be, sorry. That would be 9, 0. Hey, Nolly, my dog's barking. Hold on one second. And this would be 12, 6 right here. Pardon me one second. You know, say hey. Sorry, guys. Come here. It's okay. You're okay. Hold on. Now you say hey to everybody. What are you doing? You show them your scar? You show them your scar? You show them what a good dog you are? Hey, sit. Lay down. Oh, it was a good puppy. You say hey to everybody? All right, just relax one more second, okay? Daddy's got to finish the lesson. All right. Sorry about that, guys. Hopefully she'll stay quiet. Oh. Hopefully she'll stay quiet. She just had surgery, so she's a little needy right now, but she's recovering as well. But let me get back to this real quick. So looking at this right here, let me make sure I did this right. 0, 6, 3, 9, 6, 6, 9, 0, 12, 6. Yeah, so this is just a little graph I just made up, right? Okay, now let's say I come to you on the test, okay, and I say, hey, I want a sine or cosine function for this, right? Here's what you do, okay? First off, did it start in the middle, or did it start at the top or the bottom? Okay, start in the middle. So guess what? I'm going to go ahead and go with a, watch. I'm going to go with a sine, right? Okay. Now, do y'all see what the midline is? Oh, man. Oh, gosh. 1 second. Golly, I messed that up. Sorry. I had it right the first time. I'm doubted myself. Give me 1 second. See how this went up 3? It would go down 3, so this would be a 9, comma 3. Sorry about that at the bottom. I don't know why I changed that. Okay, so sorry, one last time. I apologize. I was just making this up at the top of my head. So you see how it's like at 6, it went up 3, it went down 3. Basically, right here, 9, 3, the 9, 0 would make sense because it would, you know, this would be different from this, which doesn't make sense. But looking at this right here, sorry about that. Essentially, since it's starting in the middle, I'm just going to go ahead and say, okay, sine, right? Now, let's think about this. What does this represent right here? Okay, that's the midline, right? Do y'all see what that is? That's 6, right? So where does that go? That goes back here. Okay, now, what would you say the amplitude is, okay? If you look at the amplitude, from 6 up to 9 and from 6 down to 3, right? The amplitude would be a 3. It started going up, right? So it needs to be positive, right? If it started going down, you just put a negative there. And all we got to do is figure out the the B value, right? What do I put in front of the X? Okay, well, let's look at this, okay? This is 0, this is 12, right? From 0 to 12, this sounds weird, but it's 12 units, right? The period is 12. Okay, so watch this. If I say 2 pi over b equals 12, right? 2 pi over b equals 12. Well, then what I'm going to do is this. I'm going to say 2 pi times 1, right? Which is 2 pi equals 12b, right? And if you divide both sides by 12, 2 divided by 12 gives you pi over 6. So the b value, that sounds weird, is pi over 6. So let me rewrite this. Y equals 3 sine pi over 6x plus 6. We were just able to find a sine, or call it a sinusoidal graph for this, right? But we found like basically a trig function that modeled this exactly, okay? So that's how you could do that to come up with that function, okay? So it's just kind of looking at the graph, the information they have, and what you got, okay? So sorry for the screw up right there, but this is the correct point, okay? I got dogs and pregnant sick ladies, and I'm halfway sick and all that stuff. So sorry for the distractions, but there you have that, okay? And now the moment you've all been waiting for. Okay, so first off, make sure you go look at the answers to all the reviews. I put all the normal reviews up. You got today, tomorrow to do all that stuff. If you shoot me an email, I should be checking those as well. So, any questions you have, I should be able to address. But for the bonus, okay, here's the bonus. I'm telling you right now, here's the bonus for the test. You remember these pesky functions? Nolly's crying. She doesn't like these things, okay? You remember these 3 pesky functions, okay? The bonus for the test is I'm going to ask you to graph one of these 3. No transformations or anything, just straight up one of these 3, okay? And these actually are very limited into what they are on the graph, because remember how x and y are both limited except for on tangent. The tangent ratio is not limited, but I want you on your own to look up these 3 parent functions. All I'm going to ask is a parent function, okay? But remember, in these cases, x's are the ratios, right? And y's are the angles, okay? So in these 3 cases right here, x's are the ratios, y's are the angles, and I'm going to ask you to graph one of these for the bonus, okay? So that will be your bonus question for Wednesday's test, okay? So once again, sorry I can't be there for you guys. I was on my way in this morning, but my wife asked me to stay with her, and who's going to deny their pregnant wife, help at home, okay? So I love you guys, but, I got to be here for my family as well. So make sure you guys work hard for that test on Wednesday, and make sure you shoot me any emails, any questions you have, and I'd be happy to help you guys out, okay? So now, come here. You want to say goodbye? You want to say goodbye to everybody? Say bye-bye? Okay, she's still learning to talk, but you guys take it easy. Make sure you watch all that, and I'll talk to you soon. Bye.